Hello everyone. Now we are starting with first internal test. We are going to discuss the question number 1 in which we have given 4 cases, and the question is write an algorithm and flowchart to solve the following pair of equation for x and y given the values of a11, a12, a13, a21, a22, a23, and the equation is in the form of a11 x1 plus a12 x2 is equal to a13 and a21 x1 plus a22 x2 is equals to a23. Now we have two sub questions. First, comment on results of case 1 and case 2 where there are when there are change of 0.001 in one of the coefficients. And second one is how interchange of equation affects the solution in case 3 and 4. For now, first we are solving for case 1 according to the Gauss elimination method, converting it into the matrix. So we have this matrix in the form of equation. So here these are the value of a11 and a21. This is the value of a12 and a22. These are the coefficient of x1 and these are the coefficient of x2. So now with the help of our above matrix, converting matrix into diagonal matrix using a pivot, that is a11 we are taking as pivot, and now we are replacing second row and performing operation that r2 minus r1 into a21 upon a11. So we will get the matrix as 2.5, 5.2, 6.2, and in the second row we will get 0, 0.00291 and 0.04952. Now we are performing forward elimination phase. We are going to put the value in this, so we will get 2.5 x1 plus 5.2 x2 is equals to c 6.2. Here we get the value of x2, that is equal to 16.9589, and now putting this x2 value in the first equation here, so we will get 2.5 x1 plus 5.2 into 16.9589, that is equal to 6.2. Here we will get x1 is equal to 6.2 minus 88.18628 upon 2.5. X value x1 is equal to minus 32.79451. Now we are solving the matrix for case 2. Here we have this matrix. By Gauss elimination, we are going to perform operations on on second row. R2 minus R1 into A21 upon A11. Converting matrix into diagonal matrix with 2.5 as pivot. Here we get the matrix 2.5, 5.2, 6.2. And for second equation we get 0, 0.00392 and 0.04952. Performing forward elimination, we get the equation 2.5 x1 plus 5.2 x2 is equal to 6.2. Here x2 is equal to 0.04952 upon 0.00392. Here we get the x2 is equal to 12.63265. And for x1 we are putting x2 value in the first equation, and we get the value of x1, that is equal to minus 23.7951. Now we are solving case 3. We have given this matrix. The above matrix can also be written as 0.0002 second row 1, 2 and 4. By Gauss elimination method, we are going to change R2 by performing R2 minus R1 into A21 upon A11. The diagonal matrix is 0.0002, 2 and 2. Then for second row we will get 0 minus 99,996 and minus 99,996. We are performing forward elimination and we will get the value of x2 that is equal to 0.99998. So x2 is equal to 0.99,998. And now we have to calculate the value of x1 by putting the value of x2 in the equation 1. We will get 0.0002 x1 plus 2 into 0.99,998 is equal to 2. Here we get x1 is equal to 2. For case 4, we perform the same operation and same method to find x1 and x2 value here also. By Gauss elimination method, we will change R2 from R2 minus R1 into A21 upon A11. The diagonal matrix will be 1, 2, 4, and in the second row we will get 0, 1.99996 and 1.99992. By performing forward elimination, we will get 1x1 plus 2x2 is equal to 4. Here we will get x2 is equals to 0.99,998, and putting this value in the equation 1 we will get x1 that is equal to 2. Now commenting on the case 1 and 2. In case 1 the values are x1 is equal to minus 32.79451 and x2 is equal to 16.9589. And in case 2 the values are x1 is equal to minus 23.7951 and x2 is equal to 12.63261. Hence we can conclude that when the values of A22 is changed by 0.001, then the result displays a big change in their x1 and x2 value. Now for second sub question, in case 3 the values are x1 is equal to 2 and x2 is equal to 0.99998, and in case 4 the values are x1 is equal to 2 and x2 is equal to 0.99998. Hence we can conclude that the interchange of the equation does not affect the solution of case 3 and case 4.